So I'm going to use this rule to fill in the function box. We know from our work on lines that that's the equation of a line. So when I fill in the function box, I'm actually finding 1, 2, 3 points that lie on the line. Let's fill in the function box. First of all, x is minus 4. So we put minus 4 in for x here. It says 2 times minus 4, which is minus 8, plus 3, which is minus 5, or negative 5. So I'll put that in here in the function box. Next, x is equal to 1. So let's put that in here. 2 times 1 is 2, plus 3, 5. Y is 5. Now it's got y is 23. So I need to make y 23 and figure out what x is. If necessary, I need to write it down. 23 equals 2x plus 3. Actually, it looks easy. 2 tens is 20 plus 3. But I can solve that equation to find x if I want to. Take 3 off both sides. Divide both sides by 2. All right, so I found out that if y is 23, x must be 10 by using that rule. But importantly, as I mentioned at the start, when I'm filling out the function box, what I'm actually finding is points that lie on the line. This here is the point minus 4, comma, minus 5. It's a point that lies on a line with x minus 4 and y minus 5 because the ordered pairs go x then y. This one here is the point 1, comma, 5. And this point here is the point 10, comma, 23. I was able to find 3 points that lie on that line by filling in the function box. And I've already plotted that line here on the board, but I can actually show you that these points lie on the line by plotting the points. So negative 4, so go across to negative 4, and then negative 5, go down to negative 5, and we land right there. That's the point negative 4, negative 5. It lies on the line. Of course it does. It obeys the rule. I got that point from putting the numbers into the rule. The second one, 1, comma 5, 1, 5, is go across 1 and up 5. You can see that that landed on the line. It lies on the line. And the last one, go across 10 and up 23. There we go, 10, 23, also lies on the line. So if a point with its x and y values satisfies the equation or the rule for the line, then clearly the point lies on the line. Well, that's one way you could determine if a point lies on a line. So here's a couple more points, 2, 7 and 5, 9, and I'm going to figure out whether they lie on that line or not. But I'm going to do it the long way. What I'm going to do is I'm going to just go, okay, you've given me the number 2. I'm going to pop it into the rule, 2x plus 3, and I'm going to see what number comes out for y. So it's equivalent to filling in a function box. You know, if I had this function box with x and y, and you gave me the number 2, I want to figure out what number goes with it. If the rule is y equals 2x plus 3. That's what I'm asking. Well, if that's the rule, and x is 2, I put a 2 in for x. 2 times 2 is 4. 4 plus 3 is 7. Now remember, when you fill out a function box, that's the same as finding a point that lies on the line. So I found the point 2, 7. Yes, if x is 2, then I end up with 7 being the y value if I use that rule. So yes, that point does lie on that line. Does the point 5, 9 lie on that line? Well, once again, I could pretend that I'm trying to find the y value that goes with x being 5, if the rule is y equals 2x plus 3, because that's what they've given me. So I put 5 into the rule for x and see what y value pops out. 2 times 5 is 10, plus 3 is 13. When x is 5, y needs to be 13 if it's going to follow that rule, if it's going to lie on that line. When x is 5, y needs to be 13. 5, 13, somewhere there. 5, 9 that they asked me about does not lie on the line, because when I put 5 in, I don't get 9, I get something else. 5, 9 is some point about here. Clearly, that point there does not lie on our green line, which is 2x plus 3. So the answer here is no. And I get that answer by going, what point should I get if x is 5? I should get 5, 13. So no, not 5, 9. Right. Now, there's another way to look at this, and I want to introduce you to this idea of left-hand side, right-hand side proofs, which is important for your work further on in mathematics. Left-hand side of the equal sign, right-hand side of the equal sign, show if they're equal, and then it's all good, or if they're not equal, then no, the point doesn't lie on the line. So, I'll do an example for you here. Does the point 411 lie on our line y equals 2x plus 3? So I write the rule down, y equals 2x plus 3. I've written the rule down. You can see that this is my left-hand side, and this is my right-hand side of my equation. Left, right. Are they equal when I substitute in the appropriate values? Does the left equal to the right? Let's find out. I'm going to consider the left-hand side first. The left-hand side is equal to y. You can see that there. That's cutting the equation in half as such, into a left and a right. And on the left, we've got y. Now, what is y? Remember, each of these ordered pairs has an x part and a y part. What is y? 11. The left-hand side equals 11. Well, not much calculation to do there. What about the right-hand side? The right-hand side equals 2x plus 3. The right-hand side of the equation is 2x plus 3. Well, what's that going to be for our point in question? Well, x is 4. So the right-hand side is going to be 2 times 4 plus 3. 8 plus 3, 11. The left-hand side is 11. The right-hand side is 11. Does the left-hand side equal the right-hand side? Yes. Therefore, the point does lie on the line because it satisfies the equation. Left-hand side equals the right-hand side, right? Therefore, the 3 dots, therefore, the left-hand side equals the right-hand side. So, the point does lie on the line. The answer is yes. That point does lie on that line. All right, let's try another one with the same line. We're using the line y equals 2x plus 3. And the question is, does the point -2, -3 lie on our line y equals 2x plus 3? So, y equals 2x plus 3. The left-hand side is equal to y. The right-hand side is equal to 2x plus 3. I want to work each one out, and if the left-hand side equals the right-hand side, the point lies on the line. If the left-hand side doesn't equal the right-hand side, then the point doesn't lie on the line. Let's have a look what happens. The left-hand side is y. Now, remember, each ordered pair is made up of an x part and a y part. So the y that I need is -3. The left-hand side is -3. The right-hand side, 2 times x, which is -2, plus 3. 2 times -2 is -4, plus 3, -1. Now, -3 or -3 does not equal -1. So, the left-hand side does not equal the right-hand side. It's an equal sign with an oblique line through it saying it's not equal. Therefore, -2 minus 3 does not lie on the line y equals 2x plus 3. Left-hand side, right-hand side equal, point lies on curve. Left-hand side, right-hand side not equal, point does not lie on curve. You need to work out the left side and the right side separately. This is pretty simple now, but later things may get more complicated. It's not good enough just to put it all in one sentence. So the type of working that you may get away with early, but it's not really very good, is to write something like the following. Is to write down -3 equals 2 minus 2 plus 3. So you can see I've substituted the -3 in for y and the -2 in for x, but I've done it all in one statement. I'm telling you not to do this. So -3 equals -1, but not. So you might write something like that. Like some people write things like that and they're sort of doing the same working but not setting it out the correct way. So separately work out the left and the right and then declare whether they're equal or not and then make your statement about whether the point lies on the line. Don't just shove the x and y straight into the equation like this. Might get away with it in year 9 maybe, but it's not the right way to set things out for the future. Okay. Here's a couple of quick questions to do. Does 311 lie on the line 2x minus 3y plus 7 equals 0? So it's given in general or standard form. Well, the left-hand side is equal to 2x minus 3y plus 7, and the right-hand side of this is equal to 0. The right-hand side of the equation on the right-hand side of the equal sign is 0. So the left-hand side is 2 times. Now, x is 3 minus 3 times y is 11 plus 7 equals 6 minus 33 plus 7 minus 20. The right-hand side is 0. Already worked out. Does minus 20 equal to 0? No, it doesn't. So does the point lie on the line? No. Right? Left-hand side not equal to right-hand side. Therefore, 311 does not lie on 2x minus 3y plus 7 equals 0. And last question, does 1, 3 lie on 2x minus 3y plus 7 equals 0? Left-hand side is 2x minus 3y plus 7. Right-hand side equals 0. The left-hand side is 2 times, now x is 1, minus 3 times y is 3, plus 7. So 2 minus 9 plus 7, it equals 0. 0, 0, yes, they're equal. The left-hand side equals the right-hand side. Therefore, the point 1, 3 lies on the line 2x minus 3y plus 7 equals 0.